Actually, I got the idea to prepare something that will introduce the Yocto project in an easy and simple way for absolute beginners. Because so before that, let me just introduce myself. I'm Talel, and I'm an embedded Linux engineer at Sophia Technologies, which is located in Tunisia, North Africa. I started with Yocto 4 years ago, and from that point, I got involved in. Actually, I'm very active in Stack Overflow, trying to always answer questions, and I'm now focusing on contributing to the Yocto documentation. Also, I'm a Yocto trainer in Tunisia, so I'm trying to make the Yocto project easy for the new communities, like the Arab community. So I got the idea to prepare something that will make this project easy, because I noticed that when giving Yocto courses and even in Stack Overflow, I always notice that beginners always struggle understanding the basics and how everything is related, and about the concepts as well, because there is a lot of stuff and lot of components and lot of libraries, and that any beginner with the Yocto project definitely will struggle to understand them, especially like the documentation is very detailed, and I have a lot of friends that come to me and say that the Yocto documentation is very long or something like that. And from that point, I started to think, why not to prepare something that will present the Yocto project in a very simple way. Also, not only the Yocto project, but also some basics about the embedded Linux world. And I tried actually to put this in a let's say a simple story, which I call the chef's story, which is BitBake, that we will see together. Okay. So starting with the basics of a Linux architecture, and this is a mandatory something that everyone needs to know. If you are a beginner, you need to master this architecture and all the components related to it. As you can see, we have the kernel space, we have the main operating system, our Linux, and the upper layer, we have the user space, and it has applications, libraries, and especially the C library. And we have the shell, which is responsible for executing, which you use in order to execute your applications or your commands. And you can see that communication between user space and kernel space happens via system calls, which is defined in what we call ABI, application binary interface. And the kernel space handles all the hardware, and it has more priority than user space. So you as a beginner, you need to understand this very well, and you need to understand deeply how everything connected and how user space applications communicate with the kernel space. Why this is so important for you to get started with the Yocto project? Because you as an embedded Linux engineer, you need to understand that the Yocto project goal is to build and assemble this an embedded a Linux distribution, and the Linux distribution composed of many components that assembles all user space and kernel space layers together. As you can see, we need what we call the root file system, which will have user space applications, libraries, the shell, and everything related with user space. And we need, alongside the kernel itself, we need a device tree blob. So you need to get familiar with what is a device tree, which is what describes the hardware and all the components that the kernel needs in order to understand where all peripherals are and how to initialize them. And of course, we need to understand what is the concept of a bootloader, such as U-boot, for example, and what is the purpose of a bootloader, which is to load the kernel and device tree into the memory and start the kernel itself, and from that point, your Linux system will be running. Also, in order to create this custom Linux distribution, you need to understand what is your target architecture is, because as we will see this in the next slides, this is very important because you cannot just simply compile any application. There is no, you cannot build a Linux distribution for all architectures. So you need to understand the difference between that and why we need to, and how we can do that. This is, we call the cross compilation and all stuff related to that topic. So this is very important stuff that you need to master in order to start understanding very well the Yocto project and how the Yocto project is, what Yocto project actually doing. So in conclusion, we need a root file system, we need a bootloader, we need kernel and its device tree. And the root file system, I mean all applications and libraries that you want to assemble in that root file system. Okay, so we need something that will automate gathering all this together and assembling all this together. You can do this manually if that's the next. That's the purpose of the build system that I will talk about later. But let's go back also to the boot process. Okay, so after understanding the Linux architecture, we need to understand how Linux system is booted. As I said, this is a generic and simple idea about boot process, because this is vendor specific thing, but I try to put something that is very common between vendors, okay, which is you have, for example, SD card or eMMC or any other type of storage, flash memory, and you have something called SPL, which is the second program loader that is responsible for initializing your memory and starting your TPL, which is third program loader, which can be U-boot or any other example. Then we need to have the boot partition, which we have the kernel and device tree and the root file system in another partition. Okay, so we need a way to build this kernel and device tree. We need a way to assemble that root file system. Okay, so we need a way to handle packaging and dependencies automatically. We need also to build the SPL. And we need a way to assemble the final image, which would be flashed into an SD card, for example. Okay, so we need a way also to build all of that for the target architecture. Okay, we need to figure out the compilation type, because it's not the same if you compile something for your native architecture, for example, x86, 64. The compilation type is not the same. For example, if you're trying to compile something for ARM 64, ARM architecture, for example, for Raspberry Pi or any other ARM architecture. Okay, So we need to weigh now, after understanding that this very well, and after understanding all the components or the major components of a Linux system and how it boots and what are the key components that we need to build and assemble together. Now we need to think of a way to automate all of that. So this is what a build system will do for us. Okay, so this is the philosophy of a build system in general. Okay, so we have the Linux source code. We have a bootloader. For example, you have Corutils, BusyBox, and other applications that you need to we need to build. So these are the components that we talked about in Linux architecture. Okay, so these components can be, for example, in-house. It can be locally on your computer, on your local server, or can be on upstream servers. Okay, so these we call sources. So now the build system needs a way to know how to compile all of the sources, how to assemble them, and what is the target architecture for what is the configuration that will help the build system know how to assemble these and what type of compilation it needs to do. So the output that we need is, of course, the packages, the final kernel image and device tree, the bootloader, the assembled root file system, the final image, and optionally we can have the software development kit as well, in order to, for example, if you have a team, for example, that don't have the build environment in their PC, for example, or you have software team that is not responsible for building the image, they can use the SDK to compile the software in order to check if in order to fix any errors that can happen during compilation, for example, before you discovering them in your Yocto build process. Okay, so talking about the configuration, the build system needs information in order to give us that output, in order to know how to deal with those sources. Okay, so the build system needs to know what Linux kernel, for example, to use, bootloader, device tree. The most important thing is the build system needs to know its target. It needs to know the target architecture. This will help the build system to figure out the toolchain, the compiler, and everything needed in order to handle or compile those sources for that target. Okay, some other examples: what C library to use, what are packages to include in the final root file system, in the root file system. Because if you are building a custom Linux distribution, then the build system cannot assume that you will add some packages. Of course, it will have a minimal packages required for booting that Linux distribution, of course, and the build system needs to know the list of packages that you need to add or to include in your root file system as well. For example, you need to know the init manager, systemd, or any other example. So other questions need to be answered as well. So this is the basic configuration that the build system needs to know about in order to do its work. Okay, so now starting with BitBake. Okay, so I always, when teaching Yocto, I always give examples of cooking, because Yocto is very, very similar with cooking. And maybe this is funny, but anytime one of my coworkers or anyone that I know when he get errors in Yocto or in BitBake, I always try to remind him with a cooking example, and he will figure out what the problem in the cooking process, and he will mirror that to the Yocto BitBake concepts, and he will figure out what is the actual solution for that problem. So BitBake is an open embedded project, which is the build system that we are talking about, which is this build system that we are talking about. Okay, so BitBake, sometimes it's called the make of distributions. So if you know make build system, it's so BitBake will it's also the build engine, which is developed in Python. Okay, so I think the first release Pookie, I think, was in 2006, and then the Yocto project was announced in, I think, 2011 or 2010, adding more tools and license handling to the Poku reference distribution. Now, if you understand very well what I was talking about, I will try to make the BitBake very clear for you, which is by saying that if you have some source application, BitBake needs something that describes that application that you have, and it needs some steps in order to execute them on those sources in order to generate the output that you need. Okay, and that's what we call in Yocto a recipe. Okay, so knowing that, BitBake now becomes our build engine, our build system, and we add to it other tools and other important stuff that will help BitBake handle not just only one recipe, but it can handle many things until it will reach the final output that we need, which is a full embedded, full Linux distribution. So now let's talk about metadata, because BitBake works. The input for BitBake is metadata, and you need as a beginner, we need to understand very well metadata and what are the types of that BitBake work with, and how all metadata files or types are connected or related to each other. So BitBake metadata is just a form of specifying what the developer wants from it and how to arrange that demand. So it's just a way to provide the configuration and the sources to the build system. As I showed you, the build system has two inputs, the configuration and the sources. So we need a way to give that input to the build system, which is BitBake. Okay, so we do this with metadata. So it's like providing the chef with raw food to use, how to cook, and what to do with the final plates. So everything that I was talking about, the steps BitBake, what BitBake can do, and how to handle sources, every component, we need to give all of that to BitBake in an organized way, which we call metadata. So BitBake, the main input for BitBake, or the main component, which is a recipe, the recipe. Okay, so a recipe describes sources that you need, that you are that you want to create a package for. For example, if you have a C, C++, or any other source code in upstream or locally that you need that you want to integrate in your final Linux distribution, then you need to create a recipe for it. The recipe then will be the input for BitBake, and BitBake will try to fetch the sources that are described in the recipe, and it will try to perform all tasks related to that recipe in order to generate the final package for that recipe. Okay, and the configuration for input are set in .conf files. Also for the recipe are files with the extension of .bb bitbake. Also, there is another type of files that ends with bb append. The idea of bb append is to append something to the original bb file. Okay, so this is very important to understand, because if you will work with official or community Yocto layers, then you need a way. Of course, you don't want to modify directly the community layers and recipes. So we need a way to modify an original recipe located in another layer that is not your layer. So bb append will help us doing that. So this will help us, for example, adding more sources to the recipe, adding patches, and modifying even tasks that are that has, for example, some bugs or issues in the original recipe. Okay, so now if you have multiple recipes that have some tasks in common, or some variables in common, or some configuration, or some data in common, then that shared data can be put together in a bb class file or an include file. Okay, so there is difference between them, but bb class, which is a class that can be inherited from a recipe, and include file also can be included from a recipe. And the difference between them, a class is mostly used to have some tasks that are common tasks between multiple recipes, and include files some configuration or tasks that are common between, for example, multiple versions of a single recipe, for example. It's not this is not a obligation, of course, but you need to understand the concept of include and BitBake classes in order to adapt them or use them accordingly. And all of these recipes, shared data, and configuration files, and bb append files are all together live in what we call layer that starts with meta and dash and any name that you will give it. Okay, this is not of course all configuration files that will go into the layer, because there are the main configuration files like the local.conf bblayers.conf file. I will cover them in a moment, but the majority of metadata will needs to be organized very well in a layer. Okay, we don't need to give everyone the freedom to put the bb file in any place in the system, because it will be messy. But one layer grouping and organizing all these recipes and bb append files, classes, include files, configuration files is a very good way for you to organize your project. If you are, for example, adding recipes, developing recipes for your custom applications, you need to create a layer, for example, to collect, organize all the recipes and all your metadata in one layer, or it can be multiple layers. So this will make your work very clean, and this will help you and your coworkers and your, for example, anyone that will work in the project to maintain the metadata that exist in your layer. Then BitBake will, as I said, will generate packages from final packages that will have the final files or binary files or whatever the recipe or anything that is specified in the recipe that will go into the final Linux in your Linux distribution. And these packages, of course, will go to the root file system. Not all the packages, of course, only the packages that you specified in your configuration to BitBake. So we have now, these are we have the recipe that you should name your recipe. It has the name and underscore, the version of the recipe, and the extension is BitBake. You have the BB append files. You have the configuration files, include files, BB class file, and you can also, in your recipe, you can have a patch file. So how a recipe, of course, can inherit a class. It can, of course, have a patch that will be applied to the sources specified in the recipe. Of course, a recipe can include an include file, and of course, anything that a BB file can do, it can be done, of course, via BB append file, because all the content of a BB append will be obviously appended, get appended to the original BB file. Of course, an include file also can specify a patch. And this also possible, which is you can inherit a class from configuration file. This is generally done from local.conf in order to inherit some class that will be inherited automatically in all recipes. Okay, an example for this is the base BB class, which will have the essential, all the tasks that will be executed by BitBake. We will see the tasks in a minute. So let's talk about recipe, which is the most important component or topic or concept that you need to understand very well, because in all your projects, Yocto project, you will deal most of the time with recipes, developing them, adding something to them, patching them. You will always deal with recipes. So a recipe in Yocto has two types. Okay, there is package recipes and there is image recipes. A package recipe is a recipe that its output is a package. It can be RPM package, Debian package, or IPK package. And image recipe output is final, is the root file system that will have all recipe package recipes that you list in a very well known variable that we will talk about. Okay, so in a layer you need the recipes in a layer are under recipes dash anything, and of course you need this is the rule for placing BB files in a layer. Okay, I note I saw many of developers always forget to create a directory in recipes, and they accidentally create a BB file under recipes folder, and when they try to build that recipe, BitBake cannot find the recipe. So make sure to follow this rule. As I said, there is a class called base.bb class that is located in Pookie that provides all necessary tasks and configuration in order to build a recipe of type package. Okay, so a recipe by default, all recipes inherit that class. So base BB class contains all tasks needed to create a package. Okay, now there is another class that is called image.bb class. The image BB class disables all package tasks and create new tasks that will handle the creation of the root file system. Okay, so because we know that all recipes inherit the base BB class, the image BB class, of course, will be inherited from. So we need a way, if we create, for example, an image recipe that you think that you will list all the packages in it, then we need a way to disable all all tasks that will create a package, because we are not creating a package, we are creating a root file system. So we need a way to disable the tasks that are related to package recipes, and we need to create new tasks that will handle creating the root file system. That's what the image BB class is for. So, like I said, a package recipe defines what sources to work with. So this is done via the SSC URI variable. How to deal with them, so the tasks that will be executed by BitBake, the build engine, and what to go into the final package via do install task and the files variable. Okay, because when you have sources and those sources you need, for example, you have a C++ application that you need to integrate it into your Linux distribution. So this is how you think about integrating it in your Linux distribution. So you need to create a recipe, develop a recipe for the sources. So you need to state in the recipe where to get those sources, how to deal with them, which is how to configure them, how to compile them, and most important, other important thing also is where to put the final output of that the compilation process in the final in the root file system. Okay, so and then BitBake will will fetch the sources and will execute all tasks, and it will try to create a package like you mentioned, like you mentioned, which in the recipe regarding where to put the final where to put the output files in the root file system. So here's how where different types of metadata located inside a layer. Okay, so all classes, BB class files located under the classes directory. BB files include files, as I said, under recipes, and you have to add another folder under that directory. And this is the layer.conf file. So this is one of the configuration files that BitBake needs in order to know how to deal with this layer, because BitBake cannot know where your recipes are and what are dependencies that you have between layers, for example, and where are the classes, what are classes under that layer. So a layer.conf file will be created, is needed for each layer, and the layer.conf file will add the path to this layer, to the BitBake environment variable, which is BB path. So with this variable, BitBake knows where to where to find the classes and include files this meta of this layer. Also, as we can see, we have we append this pattern to the BB files variable. So with this variable, BitBake will know where all the recipes are and all the BB append files are. Okay, so this configuration file is needed for every layer. Okay, so you need to organize your layer in this way. Okay, and you can also check other you can check community layers, and you can get very good examples on how to organize your layer and how to make it very simple. Yeah. So going back to the this picture of build system. So if we apply what we learned so far about the Yocto project, then the build system input is sources. And as I said, the sources are located in layers. Okay, so we have the main input file is the recipe. Okay, and we have an input, the configuration files that the build system needs in order to answer all the questions that I mentioned in the start of the slide. Okay, the main two configuration files are local.conf and bblayers.conf. You will work a lot with these two configuration files. Okay, so bblayers.conf will have all the layers that BitBake should consider. So if, for example, you are trying to build a recipe called A, for example, then BitBake will try to find A in all layers that are stated in the bblayers.conf file. So, and local.conf file is used to set very important variables and configuration that the build system needs. For example, what is the machine that you are targeting? What is the machine target that you will work on? And for example, what is the distribution and other very important configuration that needs to go into the local.conf file. So our chef, which is BitBake, needs to know where to work and how and where to find what to work with. So now, after understanding what BitBake can do and all different types of metadata and how to organize them in a layer, then BitBake now needs to know it's the environment that BitBake will use in order to accomplish all what we need. Okay, so this is done via script, which is part of the Poki project, which is OE init build environment of, and the actual BitBake binary and all other BitBake scripts are located in Poki bitbake/bin, and we have other scripts as well located under Poki/scripts. So this script actually will try to initialize your environment by adding the scripts and the binary folder to the path environment variable. So this way you will have access to shell will know when you type bitbake command, the shell will know where to find, it will find bitbake because the path is added to the path environment variable. Also, we have the Python path environment variables that will be point to the bitbake library, and we have the build dir environment variable that will point to the actual build directory. Okay, so imagine this as the kitchen for the chef. Okay, so now we have the configuration directory that will have the local.conf and bblayers.conf files. Okay, in this way, now bitbake will use those environment variables in order to know which all the components, where are all the components and all the configuration, where are all the configuration files are located. Okay, you will have a downloads directory. This is the default location for downloads, and you will have also the cache, and now you will have a TMP folder that will this is the actual place that bitbake will do all the work, which is unpacking the sources that are fetched into the downloads directory and executing all the tasks on those sources and creating the final packages and the final image and the root file system. Okay, so I will give a very detailed example about the TMP work directory. So you need to understand very well what this script is doing, what is the importance of this script, because sometimes when you close your terminal, so you need to you will lose all the environment that is set by this script. So you need to set, or you need to source the script again in each terminal. So you need also to make sure that you will give this script the path to the actual build directory that you are working on. As you can see here, you have the source command, source poki, for example, slash the name of the script, and you have to give it the path to the build directory that you are working on. So you need to be careful here, because if you give it another path, another build directory will be created with the default configuration. And if you will do bitbake again after building, for example, for 4 hours, then everything will be started from the start, and you will be surprised, because you just you will say the build is done, so why bitbake is doing all of this again? So so make sure that you always source the right path for the build directory that you are working on. So after introducing the kitchen to the chef, so bitbake now knows where to work and where local.conf, bblayers.conf are located, and where everything is located. Now the chef, which is bitbake, will analyze the environment and collects final information about what layers to consider, what recipe, where are all the recipes, and it will initialize the rest of all of variables that bitbake will work with. Okay, so all configuration is the configuration is set of variables that will be used by the chef in order to know where to find things. As I said, in local.conf, you will have machine, for example, and distro, and machine and distro will guide BitBake to another configuration files that will have another set of variables that will describe to BitBake other information needed in order to build the sources for the right target. Okay, so there is also a bitbake.conf file located under in bitbake meta /conf. bitbake.conf. So this is default configuration with a lot of other variables. So as I said, BitBake needs to know what type of compilation it needs to perform. Okay, is it native? Was it a cross compilation or cross compilation, for example? So there are a set of variables in bitbake.conf. Okay, that will be set or modified, of course, according to what machine you are using, what architecture you are using. So I will talk about machines, what is machine in what is BSP in Yocto after this. So you need now to understand from this that this is automatically handled, and this is updated according to the type of compilation. So this is all based on your target architecture and some other variables as well. So BitBake will use these variables in order to compile or to handle all your recipes. This is an example for a recipe called hello, and there is hello lib. Okay, so this is just a sample example. Hello lib, you specify where are your sources, okay, via the src URI variable, and in this example, the scheme or the type of this source is git. So another variable would be needed, which is srcrev, to specify the commit for what commit to fetch or clone. This is an example of a recipe called hello that has two versions, and the two versions have the same sources and same dependencies and same there's something in common between two of the versions. So that's why there is hello.include that holds the common variables between the two versions, and both of recipe versions will include the hello.include file. In this example, there is require keyword. Also, there is include. So include, when you specify this with require keyword, BitBake will try to include the hello.inc file. If it cannot find it, it will fail. So and include. So include and require are the same, but require, as the name states, BitBake, this file is required, and BitBake will fail if this file is not found. So this is just a simple example. Now I will give you a very detailed example about how BitBake handles a recipe, for example, inside the working directory of a recipe. So this is, I always concentrate and I always try to concentrate on making this very simple for beginners, because the working directory of a recipe is a very important concept that you need to understand, and you need to master the content of a working directory, and so this will help you debug your recipe and find out if your recipe is being handled as you intended. For example, if the final package is created like what you stated in the recipe BB file, for example. So you have the build directory. We have TMP and downloads. Okay. So inside TMP, we have the work directory, and we have another one, another directory inside work that not just one. We have a folder, different folders that some variable controls the path of those variables. For example, this depends on, as you can see here, a variable called package arch. Okay. BitBake organizes recipes, working directories of all recipes according to their architecture. Because, for example, you will have a folder that will have all recipes that are related to your machine, recipes that are for your architecture, and recipes that are the native recipes that BitBake will use natively in order to handle other recipes. Okay, so just keep in mind that because you need to understand, if you are developing a recipe, you need to understand what is the architecture specified for that recipe. So sometimes you need a recipe. You will develop a recipe for your machine, for example, for a target machine. Sometimes you need to develop another recipe that will be used during compilation of another recipe, for example, and you need some native tool to handle another recipe. So you need to understand the difference between all of these directories, but all of them have working directories of all recipes inside them. Okay, so this is an example of a recipe that the sources are from GitHub. Okay, so BitBake will start doing the do fetch task, which is fetching the sources into the Git directory inside downloads folder directory. Okay. So then this is the actual working directory for the hello recipe. Okay, as you can see, you have the name of the folder having the name of the recipe, and another one for the version and the release of the recipe, because a recipe can have multiple versions and releases. So then BitBake will unpack the sources fetched in the downloads directory under the Git folder inside the working directory of the recipe. This is specific to the Git sources. Then what BitBake needs to do is so these are just this is an example what the sources that are fetched from Git, just a sample make file and hello.c file. Okay, then BitBake will, if there are some patches that are specified within the recipes, src URI variable, then BitBake will try to will execute the do patch task to apply them on the sources unpacked and in the working directory. Okay, now let's assume that our hello recipe depends on a shared library, for example. Okay, so this is a very important concept that you need to understand, which is the dependencies handling in Yocto. Okay, so if you have a recipe that depends it depends at compile time on something else, on some shared library, for example, or any other thing that library, any other library, or any other tool that at compile time, then you need to the dependency itself needs to be a recipe as well. Okay, this is how BitBake handles dependencies between recipes. So if a recipe depends on a library, then another recipe needs to provide that library. Because, for example, if you have a HelloLib recipe that will provide the shared library needed at compile time by the Hello recipe, then BitBake will perform the do populate sysroot task. This will prepare the output files from the HelloLib recipe into the sysroot distdir directory. This is also under the working directory of the HelloLib recipe. Then it will copy these files via the do prepare recipe sysroot task of the hello recipe. So every recipe in the working directory of any recipe, there is a directory called recipe sysroot, which will be handled in the recipe as a root file system of that recipe. So if you have, for example, include stdio.h in your source code, then you need that stdio.h, you need that header file inside the recipe sysroot under, for example, usr/include, for example. So in our example, hello needs a shared library. So the shared library needs to be located under recipe sysroot folder. So BitBake knows that hello recipe depends at compile time, depends of hello lib recipe, then it will run all tasks of hello lib in order to make sure that we have the files needed by hello at compile time, and it will prepare those files into the recipe sysroot of the hello recipe. Okay, this is just an example. These are files coming from the working directory sysroot distdir folder of the hello lib recipe. Then BitBake will continue with the do configure, do compile tasks that will generate, will compile our hello.c file, generate the binary hello. Now we need to specify where we want the hello binary to go in the root file system. Okay, this way the final package, the package of the recipe will be created. Okay, so there is a folder, a directory called image under every working directory that is called the holding area. Okay, so if we want anything, you will put in under the image directory will be so think about the image folder as your slash of the root file system. Okay, so anything you will put under the image directory will go as it is and be assembled in a package, and the package will be installed in the root file system. So in this example, we want the hello binary to go under usr/bin. So we create usr and /bin under the image directory, and we copy our hello binary under that directory. So this is done via the do install task. Okay, then we continue with the creating the actual package from the package directory. So the image directory will be copied to a package directory, and the package directory will be split into different or multiple packages. And this is done via controlling or checking on a variable called files. So, for example, any given recipe, any recipe can produce multiple packages. So this depends on what files are generated by your recipe. For example, if your recipe provides documentation, shared library, a binary, for example, it's recommended to separate those files in different packages. This way, you will only specify what package that you need for the root file system, because not all the, for example, if you need the development package that will have the header files, you will specify only the package that will provide the header files. Okay, so there is another a variable called package classes that will control what package type that will be what package type will BitBake generate. Okay, you can specify RPM, Debian, and APK. Okay, you can specify all of them. BitBake has Poki has a class for each of these types. Okay, and every type that you will specify in package classes will be inherited, as I said, globally for all packages. Okay, so for example, if you specify package RPM, BitBake will inherit package RPM class for all recipes, and a new task will be added to every recipe that will produce the final produce the RPM package. Okay, so if you want, I created a map, a very detailed map about this concept. You can find in the official Yocto documentation, which is this map. So you can try to understand this map. I try to add all information needed to understand many parts of this map. Okay, regarding the all folders and the working directory details, and the tasks that will be performed by BitBake in order to generate the final the package for that recipe. Okay, and how dependencies, compile time dependencies, is handled by BitBake. So this is very detailed map that I encourage everyone to have a look at. So okay, so after this, we now, after understanding how to develop a recipe and what the types of a recipe, you need to understand how an image recipe works. Okay, so as I said, an image recipe is just a simple recipe, but that does not have the default tasks that are performed to generate a package. But an image recipe has tasks that are used to generate a root file system. Okay, in order to generate a root file system, BitBake needs to know what are the packages that will go into the root file system. Okay, this is specified via the image install variable. Okay, there is package install variable as well. So image install is the very known variable to use. Okay, this is an example custom image.bb that inherits core image. The core image is a
Hey,
class.
Talel, how are we doing on time there? Are we getting close to the end? We're like 20 seconds before the next talk's supposed to start. Sorry to interrupt.
Um, I did I did not notice the time. I'm very sorry for that, but I will try to quickly end this. Um, so the image is just a simple recipe that will have all recipes packages from the deploy directory, okay, and the image recipe itself is a recipe that has a working directory, and there is a root file system directory that will hold the final root file system. Okay, so we have useful layers, community layers that you will have find in git yoctoproject.org. Okay, you can there's many useful classes you can use for CMake, systemd, and other examples. Okay, so just a quick note about BSP. So every machine that you specify in local.conf will point to a configuration file that is located under layer/conf/machine. And in this configuration file, you will specify what kernel, what bootloader, what is the architecture to use. So this is an example for Raspberry Pi. What is the kernel to use, what is the architecture to use, and this answers all the questions we asked in the beginning. Now BitBake knows what architecture to use, what kernel to use, device tree, etc., and what image file structure to build. And this is how BitBake now knows what type of compilation to do, and it will go through the list of packages that you specify in your recipe image, and it will perform all the tasks required for all recipes, and it will assemble that image for you. Okay, also there is other techniques and ways to I call them advanced cooking techniques in order to debug and use BitBake in a more powerful way. Okay, there's tools of also that can help you handle your build and your recipes in more advanced way. You can take a look at this in the others in your more time. So what's next? So there is a lot of other concepts that you can also have a look at. For example, package config, how to create a distro, and other concepts as a beginner. So you need to have a look at also. And I really encourage you as a beginner to check documentation, and you are welcome also to the IRC channels and mailing list in order to understand more and understand more the Yocto project.